The steel ball mass M is fastened to a line cord, the length L, and released when the cord is horizontal, illustrated by this diagram, the length L. As the bottom of its path, meaning at this point, the ball strikes a hard plastic block of the mass 4m. Initially at rest on the frictionless surface, the collision is elastic. Okay, meaning the kinetic energy is the same. Find the tension in the cord of the ball at the height above its lowest position is 1/2 L. Okay, find the tension when the height of the ball is here, and that height is 1/2 L. This height equal half of L. Find the tension. Okay. At that point, the cord is like this. The cord there. Let me draw another diagram, huh? This is the ball, free body diagram. This is gravity, W. Okay, the tension center toward the center mass. To have the height equal half of L here, this angle, this height is also L over 2, huh? L over 2, and therefore this angle is 30 degrees. Can it be like a rectangle like this? No, I don't think so. The height. Okay, let's consider this angle instead. So that this height is L over 2. L over 2. And this is L. So this is the adjacent of this angle theta, huh? This is the hypotenuse, cosine of this angle theta, cosine theta, the adjacent, which is L over 2 over the hypotenuse L, which is 1/2, huh? Cosine theta is 1/2, and therefore theta is 60 degrees, huh? Tension minus mg, the component which is in this direction. Okay, ml over L. Okay, got it now. I forgot that kind of solution. Okay, for the gravity, mg weight here equal mg. We have another. We can resolve it into the two components. One component like this, and the other component which is tangent to the path. Huh? Let's call this W1. This component will be this angle equal to. It is equal to this angle, which is 30 degrees. Which is 30 degrees. Okay, because this angle here is 60 degrees. Okay. Yeah, this angle is 30 degrees. So W1 here, W1 is equal to mg times sine of the 30 degrees. And we will have this following equation. The tension minus that W1 will be equal to the centrifugal force. The sum of those two forces is the centrifugal force in the red color here, Fc. Okay. And that centrifugal force is pointing toward the center, the hang point. Hang point of this object. That Fc is mv squared over the radius, which is the length of the rod of the string. Okay. And this W1 is mg times sine of 30 degrees. The tension is what we need to find. This is mv squared, okay, over L. So the next thing we need to find the speed v here. We don't know it yet, okay? We need to find it by using the conservation of energy. At the top, the kinetic energy is 0 and potential energy is maximum. Chosen the lowest point here to have 0 potential. So at the top point, the potential is mgh, and h is the length of the string. Okay. That potential energy convert into kinetic energy 1/2 mv squared at this location. Let's call this location A, huh? Okay.
Yes.
And the potential there, mg. Now the height is L over 2. From this equation, we can find the v square and then plug in here to find the tension. Okay.
Yes.
Okay. So mv square 1/2 equal to mgl minus mg L over 2, which is half of mg, huh? mgl, half of mgl, because 1 minus 1/2 is 1/2. Okay, and then we can simplify the 1/2. So mv square equal to this thing. Now replacing it here. Okay, so we have T minus mg, sine of 30 degrees is 1/2, okay, equal to mv square, which is equal to mgl, okay, lg, okay, over L, simplify them. So the tension is mg minus half m plus what, half mg, huh? The next thing, the speed of the block immediately after the collision. Conservation of momentum after collision. Do they stick together? No, they didn't say so. Strike it. The mass 4m. E elastic. Okay. It will not enough space to write. Have to write smaller size of the pen. After the collision. I'm thinking of using 2 equations. Conservation of momentum is 1 equation, and conservation of kinetic energy at the second equation. Okay, let's try it. Firstly, conservation of momentum, huh? Of the small ball is the mass m here. Its velocity we determine from this equation, mv square equal mgl, huh? Which means V is mgl square root, huh? Sorry, remove the m. gl square root only. M times v there before the collision. Oh, sorry. This is the velocity at the height, half of the L. At the lowest point, we need to use the conservation of momentum again to find, energy to find the velocity of the ball right before hitting the block, huh? Of the ball, the small ball, right before hitting the block. To find that speed, we use the conservation of energy again. Mg times the height. The height is the L, huh? L equal to that 1/2 mv square. Mv. 1/2 mv square. So that speed is 2 gl square root. Okay, before hitting the block. Now conservation of momentum. Momentum is the first step, huh? The second step. Conservation of momentum as follow. The mass of the ball times its speed there, 2gh, 2gl, equal to the mass of the ball times its speed after the collision, v2, huh? Let's call v1. v1 after the collision. We don't know it. We will find it. Plus the mass of the block, which is 4m. And the speed of the block v2, we don't know it also. To find the two values v1 and v2, this is one equation. We need another equation, which is conservation of energy. Kinetic energy in the collision, in this elastic collision, the elastic collision. Potential energy is the same. Kinetic energy the same, elastic collision, meaning 1/2 m times this v square. This is the v. We can also call it v0 before collision. 2 gl, 2 gl, because we squared it, and therefore there is no more the square root, huh? Okay. Yes. Kinetic energy. This is v0 square. This is before the collision. This is kinetic energy. After the collision, we have 1/2 of m times v1 square, and another thing, 1/2 of 4m, the block, 4m times v2 square. So we have the second equation. Solving this system of the two equations, we will get the values v1 and v2. Do we know L, the length? No, we don't. Meaning we have to represent v1 and v2 in terms of m and L, making it complicated. Okay, so we have two equations like this. To solve it, you can use the substitution method, which is representing one variable v1 or v2 in terms of the other variable, and then substitute in the second equation. Okay.
Yes.
What is the question? The speed of the block, meaning we need to find v2, and therefore I will represent v1 in terms of v2 from the first equation, and then plug that v1 in the second equation. Okay. Change to another color, white color. From 1, I want to represent 1. I want to represent v1. We can simplify the mass of the equation, So v1 is equal to square root of 2gx, meaning gl minus 4v2, Then plug in here. So we have 1/2 of m times 2gh, 2gl equal 1/2 v1 2gl square root minus 4v2 square root, plus 1/2. We remove m from the equation here also, Okay.
Yes.
What do you rate this one? You rate this 1/2. 4 here, so 4 over 2. 4 over 2 is 2. 2 here. v2 square. We are finding v2, Now expanding this square is equal to 2gl minus 4v2. Wait, sorry. The square root side only goes to here. A minus b are all square identity, Binomial expansion, minus 2 times 4v2, and then times square root of 2gl, right? And plus 16v2 square, right?
Yes.
Then plus 2v2 square equal to this gl. You see that for complicated problem like this, you need to double check after finishing it, or be very careful with each single step. Okay.
Yes.
GL here, multiplying the 1 to the bracket. So this is GL, no more than the 2, 4v2 square root of 2gl, and 8, not 16, 8v2 square, and then add it with 2v2 square here, so that makes 10. Okay, simplifying this one, equal to 0 on the left, minus 4v2 square root of gl. Almost done. Yeah, beautiful. So see here, v2 making common factor, 10 minus 10v2 minus 4 square root of gl equals 0, right? And of course v2 different from 0, so the thing inside the bracket, this one must be 0, and therefore v2 is 4g square root of, 2gl. I forgot the 2 here. 2gl. Again, 2gl, not 1gl. 2gl over 10, which is simplified as 2 over 5 of 2gl, which is perfectly the answer. Do it again, like this afternoon, as soon as possible.
Yes.
So the method again is finding the speed before hitting the block, and then apply the two conservation laws: conservation of momentum and conservation of kinetic energy. Kinetic energy, not energy in general, because the total kind of energy, including potential and thermal, is complicated. So we just need to concern about kinetic energy conservation for a elastic collision, and then try solving the two equations, and then you get the answer. Let's move on to the next one. To what height will the ball rebound after the collision? Okay, the last one is easy because now we have V2, so we can plug back into this equation to find V1, meaning the velocity, the speed of the ball bouncing off to the left from the block, and then use the conservation of energy again. The kinetic energy of the ball after bouncing will convert into the potential energy maximum, and we can find the maximum height that it goes up after bouncing. Okay. Yes. So V2 here. Now go back to V1. 2GL minus 4V2. Okay. So that will be a negative value, which is perfectly good. Makes sense because the speed, the velocity of the third ball must be in the opposite direction. V1 now is 2GL minus 4V2. Going back from the representation here, 2GL minus 4V2. Okay, 2GL minus 4 times of 2 and 2 over 5 of 2GL. So that is 5 over 5, 5 over 5 minus 8 over 5, right? 2GL. That is minus negative over 8, negative 3 over 8, sorry, over 5. 3 over 5 square root of 2GL. It's negative going backward, going to the left. That perfectly makes sense. Backward to the left. Bouncing, bouncing. There. So now use the conservation of energy again. With kinetic energy, 1/2 the mass of the ball times the square of the speed, 3 over 5 to GL square root. This is kinetic energy, convert totally into the potential mg times the new height max that we want to find. Okay?
Yes.
That we want to find. So solving this equation, simplifying the mass easily. And where this one is 9 over 25 times 250. 2GL on the top here, 2 over 50 anyway, equal G times X max. Okay, and then simplify G. So X max is 9 over 25 meter, 9 over 5 L. Perfectly equal, the same with the answer, the mass scheme, 9 over 5 or 36 L. L is the length of the rod or the string.